Okay, so I'm hoping everything is all right. I started live streaming just 1 second ago. I'm using the Intel QuickSync now, so it shouldn't be much of an issue in terms of my CPU usage. I wish not to drop any frames, which I believe I will not. Okay, cool. I think we're all right then. Okay, welcome everybody. This is a little live stream. I'm going to be writing an HTTP library for R. This HTTP library, of course, will be, what do you call that? Asynchronous. So we're going to be using the tools we usually use. We're going to be using R. We're going to be using promises later. We're going to be using Rust for the multi-threading and the asynchronous part of the code. And I hope you have a lot to learn from this. I hope it's worth your time. I'm gonna be sharing before I start the stream. I'm gonna be sharing this on Twitter, on whatever social media, so that everyone can be up to date on what I'm doing. So give me just 1 second. I do that, and we can start the stream. So I haven't done this in a while, in a very long while. So I hope I hope I'm not very rusty. Not like no pun intended. So yeah, let's see how this goes. Um, let's see. Okay, I'm getting into Twitter. On X. Sorry, I barely come into this website, so I'm gonna be if anyone wants to learn some async R with, I will be writing an async HTTP library for R in the stream right now. Awesome. Let me share. So my audio quality is not going to be the best. I'm just going to be like straight up about that. I'm on my parents' house currently, and that has caused, like, I don't have my usual microphone here. I bought a new keyboard, so I have it right here, and I'm trying to get used to it. So I decided, like, hey, what's the best way to get used to a new keyboard? It's typing a lot, and what a better way to type a lot than to write some sort of cool project. Um, Let me check that everything seems to be going all right. So I think we can start the stream. Amazing, amazing, amazing. Let's see. So I'm gonna start sharing my screen. Well, first I'm gonna get into my project. CD projects, videos. Let me enter here. Async, async HTTP, and we'll start from there. Awesome, awesome, awesome. So I'm gonna show my screen now. I'm gonna resize my face to make it a little bit smaller. And I'm gonna put in the bottom half. Should I make it even smaller? Should I make it bigger? No, I think there's all right. Awesome. Okay, so I'm gonna be checking the chat. As usual, I don't think I'm gonna have many viewers live. So again, I'm gonna be checking it either way. So if you wanna send a question or something, go right ahead. I'll 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 be very happy to answer any questions. I'm gonna share this as well on my. Give me 1 second. I'm just looking where to share my live stream to hopefully get at least a viewer or two. Let me share it through. So, there you go. Okay, I think I got it. So here we have async HTTP. I'm gonna make this as not as big as possible, but I think big enough so that you guys can have a clear view of my screen. And we're gonna have to create a name for this library. Okay, so let's start by going to R, use this, create package. What's a good name for an HTTP library? Hmm. So I'm gonna be using as a backend, well, not a backend. I'm gonna be basically just wrapping around URAC library in Rust. So maybe ARAC would be a good name, like asynchronous requests, or just async HTTP might just be a good name. I don't know. Let's just call it async HTTP. It'll be really boring. I'm not really. And let me check that I am on my get working directory. Okay, I'm inside async HTTP. Awesome. So I'm going to use our extender, use extender, our extender cran, use cran defaults. Yes. No, absolutely not. No. For sure. Why did I do that? Let me, yes, I want to override it. Awesome. Awesome, awesome, awesome. Let's leave here and let's cd into our async HTTP and let's get right into it. Awesome. So the first thing we're going to be needing to do before even getting like started with our Rust code, I think would be to write and like the basics of how we want our API to look. So let's create a how do we want to do this? Because I have absolutely no idea what to like. We could just try to copy the HTTPR to um, way of doing things, but I'm not sure if that's what we're gonna go for. This is like a really minimal HTTP library. If you would like to build something on top of it that's way better, go ahead. Um, you're more than invited to do it. So I'm gonna try to make it as minimal as possible. So I think I'm gonna start by literally just having verbs, having a way to set the headers, a way to set the body, and I think that's gonna be it for now. So let's start with verbs dot r. So we're gonna have our post function. Our post function will take in a URL, and we're gonna have here a to do wrap. Sure. So let's start with post, and let's have our get, our put, our delete. Are there any other HTTP verbs that I'm perhaps forgetting? Perhaps there are other ones, but I think we can start with these ones. We're also gonna have an set header, which should be a function that takes in like a request, sure, a header name and a header value. I think this is okay. So the reason I'm doing this stream is because I'm learning a new keyword and I need to type quite a lot of code to get to finish getting used to it. So that's kind of like what I'm going for. Okay, so this is gonna be our verbs, right? So this is what we're gonna be doing. For the body, yeah, let's just create a little function called body. Function, this should take a request and a body. We should not play body, it's gonna confuse with recursion. Contents to do. body. And we should have a way to send request. So first we're gonna focus on sending the request. We can then focus on what? On getting a response, right? So let's first focus on sending a request, even if we don't handle responses yet. Awesome. So this we're gonna be what we're gonna be doing. Amazing. So I'm gonna come here, I'm gonna cd into source Rust. I'm gonna cargo add definitely extender API. We already have extender API, but we're gonna have to add the SERDI um, the what? The SERDI thingy, the SERDI feature. And I'm gonna add. I think we're gonna be using UREC definitely. So we're gonna be cargo add UREC cargo. We're also gonna be wanting to add rayon for the thread pool. Cargo sir. Why am I forgetting to put the add rayon for the thread pool? We could use Tokyo, but I don't really want to use Tokyo. Not because there's anything wrong with Tokyo, but I think it's a little bit too bloated for the specific use case of creating a library for R. Awesome. So now let's go into our live.rs. Let's delete all of this. And let's create here extender. And now before going with anything with extender, let's start by creating a struct. This is going to be a request builder. Yes, a request builder. So the request builder should be a struct that contains all the information we need to store the build of a request. So what is it gonna need? It's definitely gonna need a URL, which should be in this case, I think, a string. It should have some headers, which could be a hash map. Do we want a hash map? Do we want to perhaps just a vector of headers and values? Because I think in HTTP you can have like multiple of the same header. Let me look that up. Can you have multiple Roth arrays, multiple headers of the same key and HTTP? Is that a thing? Yet multiple messages header fields in the same field may present in a message only if the entire field value for that header is defined as a comma separated list. But that's a response header with the same name. Is this? It's commonly used for set cookie, right? For this, but this is for the response. Okay, so let's just. This is perhaps an edge case. So let's just not implement this. Let's have a hash map of a string. Or even better, an rster, which is like just a wrapper for a character type in R, which could be beneficial due to the fact that we can, how do you call that? I mean, it should be easier to clone, it should be cheaper. And this should also point to another rster. Amazing. Let's import hash map. Amazing. And we should have a body, which should be a vector of bytes. So where's the here? U8. Okay, so we have a request. Now let's actually do extender. So control extendr. Um, implement request builder. Amazing. And implement request builder. Oh, what did I do? There you go. Okay, we're also going to need an HTTP client. So let's create here struct HTTP client. The HTTP client should include a thread pool, which we're going to be using Rayon thread pool. And for the HTTP let's do the agent is what's called in UREC. So UREC agent. This should be all right. Awesome. We're also going to need an implementation block for our HTTP client. Amazing. Let's save here. Looks like everything's all right. So let's do here implement HTTP client. Cool. So let's implement a request builder. So let's start by creating a function new. And the function you should take perhaps a verb, which should be perhaps how do you call it, a string slice and an URL, which should also probably be a string slice. And it should return, now we can have extender converted automatically to a string. We need an owned, although we are using rster, so perhaps strings, because it's going to, so now let URL equals URL dot, so we are to do, what did I do wrong? Oh yeah, it should return itself. So here, dot next, that first chunk, second do strings. We can do get, so we can do a get 0, right? Because what if the user passes return the first element of the slice or none? So this should be of type option rster, right? So for now, I'm going to do an expect. URL must be of size 1. Amazing, and let's clone it. Just for context, cloning an rster is just basically just adds 1 to the reference count. Awesome, awesome, awesome. Oh, and thinking about it, we're gonna need a verb. So verb and verb. We should make it really an enum. So let's create enum HTTP verb, or perhaps UREC has one. So UREC verb request. Is there really not a verb? Okay, so let's just create here enum HTTP verb, and let's have our get, our post, our put, and our delete. And verb here, and HTTP verb. No, not client, verb. There you go. Amazing. So now let's do let verb in equals match our verb. In this case, it's a string, but we're going to be converting it to the enum. Oh, I hate this. So I get confused in the keyboard. These are the arrow keys, and these two are my little curly brace keys, and I confuse them all the time. So if you see me like going to the line below, it's because I'm not clicking the curly brace. I'm clicking the how do you call that? The the an arrow key. Okay, awesome. So if it's get, we're gonna point to HTTP verb get. If we get a post, um, let's do HTTP verb post. If we get a, do we have anyone in chat? We don't. If we get a put, we're gonna be passing to an HTTP verb put. And finally, if we get a delete, we're gonna pass over to HTTP verb delete. Amazing. And then we just do here HTTP. Of course, we need to tell it what to do. This case is really not exhaustive. So let's do underscore points to what? Panic. HTTP verb. Let's do it in single quotes. Is not supported. So I misspelled verb. Awesome. And here we can just return our request builder with the URL. We had set the URL to string. Let's do an rster. So only before sending the request do we want to have owned values. So URL verb. For our headers, we're gonna want a hash map new, and for our body, we're gonna want a awesome. So we have our request builder. Let's add our function set header. This should take a mutable reference to self. It should take a what? A header name strings and a header value, which should also be strings. Is there anyone check? Not yet. Awesome. So this should be let header name equals header name dot first. This is the thing with R. You always need to, I mean, unless you want an owned value with like a string or something, which in this case I think we don't want. Or do we? Like I'm still not very sure if we want an owned value yet. We can go ahead and change it. Header name must be length 1. In R, you kind of always have to check if something is length 1 or not. So header value, header value. So yeah, header value must also be length 1. We can change this later. This is an rster, let's clone. The reason, I mean, this is owned according to Rust's ownership values, but it's still owned by R, if you know what I mean. Like it's in the R world. So because it's in the R world, when we clone it, what we're just doing is incrementing the reference count in the for the garbage collector, not to eat it up. And that's the way we own it, but it's still the garbage collector is the one that controls that value. That's why it's not thread safe to pass it on between threads, because if we try to send it throughout our threads, we're going to run into the issue that the garbage collector might think it's not being used, but it's actually being used by another thread. Or if we clone it on another thread, we might increment it on atomic counter, and that might lead to a data race and the like all of the challenges of doing concurrent multi-threaded programming. But here we have a her value, and we can just do self dot set header, no, self dot headers dot insert, and I think an arser is not hashable. So because it is not hashable, that just basically ruined my plans, because or else I would have the get method. So this would be a string, not a strings. And basically, I'm just going to have to change this to a string. I'm going to have to change this to a string. And I just delete all of this, and I just do self.headers.insert. And I just do header name, comma, header value. And we are done. Yep. So we're going to have to basically have it owned in the Rust root. Okay. Awesome. And now we need to set the body. So function set, how did I call it here in the verbs that are body? So function set body, it's going to take a mutable reference to self, and we're going to need to take a body, which should be an R object, because we want it to be able to send, like to be pretty much anything. I guess that's where we're going to want. I don't know what we want, because I would love to be able to use like the serialize and deserialize methods, but not all HTTP requests are JSON. But I also want the user to be able to send raw data. So let's just keep it that simple. So let's do set body raw. And for this, we're gonna want to pass in a raw. Is that a type? Yes, it is. Okay. So self.body.clear, just in case we have something in there we want to delete it. Self.body dot extend from slice, and I think we can do body dot as bytes as slice. Yep. So I think the extend from slice clones and appends iterates over this slice. Other clones each element and appends it into the back. The other slice is traversed in order. Except that it is specialized to work with slices. If we get a if and when we get specialization, this function will likely be deprecated, but still available. Awesome. So we have our set body raw. For now, I think we're gonna focus on just passing in raw bytes directly to the function. We can add other methods to set the body to different things, for example, JSON and stuff, but that will come up later. Awesome. And we're also going to need a function called send request, right? So the send request will have to take in a reference to self, perhaps a mutable reference. I'm going to explain why in a second, why a mutable reference. And it's going to have to take in an HTTP client, which should be a reference to the HTTP client. Amazing. Um, and now what we're going to want to do is do the following: HTTP client dot redpool dot spawn. Spawns an asynchronous task in this redpool. This task will run in the implicit level scope, which means it may outlast the current stack height, therefore gonna capture references. Yes, this is what I want. Is this blocking spawn function? This doesn't return anything. Yep, so this is fine. So spawn, this is probably gonna take in a movable, well not a movable, but like a move, a owned, what do you call that? I don't know what the name of. And let's do here a to do so that we don't lose the. Awesome. So we're gonna need here to let first let's add here a derive and let's make this clone and copy. First of all, copy. Yes, awesome. So we're gonna need body because we're gonna need to move body, right? So body is gonna be equal to, let's do an empty request builder. Let's create a, is that something we want? Because let's do here URL. Let's make this also a string so that we can have an ownership over it. Now let's derive a default implementation. So we're going to make this mutable. And what we are going to do is that we are going to standard mem swap self and add mute empty request builder. Why am I not empty request builder? So basically what I just did is I swapped the memory contents of both request builders. And in this way now I own whatever's here in this request builder. Because it's not gonna be empty once I do this memory swap. So let's put in a comment. Why did I do this? I want to own the request builder, but the extender API does not allow for owned self, so I have to create a new instance and swap the pointers. Awesome. That should be okay. So now that I have this, I can move the request into it. And I can do a urec, so I can do a match request builder. Why am I not getting the intelligence I want? So match request builder dot ver. Perhaps I need to restart my session, but I don't care enough right now. So http ver get, and if we get, we're gonna want to do a urec get. We're gonna want to get the request builder dot URL. This would have to be borrowed so that we can cast it into a string slice. Set. So I'm gonna do this. I'm gonna do let request equals. Awesome. So here we have a request. Request dot set takes self, right? So we're gonna need a for header name, header value, and request builder dot headers. Request equals request dot set, and dot set, if I'm not wrong, takes in a header, so it would be add header name and add, where's the add header value. Amazing. Set the comment is set the headers. How do I set the body? Okay, so the body is sent at the moment of doing the request. Okay, so send bytes. And this would be okay. So I want to do it with an agent. So if I'm not wrong, the agent is cheaply clonable, so I should be able to do agent dot. Yes, exactly. So I should be able to do match errors request here. So for now, I'm gonna do nothing with the request. Later on, I will. So later on, I'm gonna, because here this doesn't return a join handle, right? So Yeah, just likely need to move yes and no, but is there a let's look for a rust rayon. Rust rust rayon. Red. Okay, so what's this installment do? Execute and any attempt to use general scope will then operate within that thread pool. Okay, yeah, I get it. This is not what I want. Broadcast. No. Current number threads, current thread join. Executes upper A and upper B. This is not what I want. Creates a scope that executes this in the thread pool point to self-install scope. This is not what I want. In place, spawn FIFO. This is little scope, which means that it may outlast frames to spawn. Does this not have like a join handle? What is R here? Scope. Yeah, because we could have like a one shot. I guess that's not the worst. Sure. We need a one shot sort of thing. So this should probably let one shot equal standard sync. One slot. A synchronization period which cannot normally be written to only once. This type is a thread safe one cell and can be used to in many simple cases. You can use lazy lock instead to get the benefits of this type with less effort. Lazy lock looks like a T because it initializes with F on D or F once lock shines. This lock is too simple to support a given case, as lazy lock doesn't allow additional inputs. Its function, but this is not what I want. So is there an equivalent of Tokyo one shot? One shot on standard? Because this is a one shot channel, right? So standard sync channel. Because this is a multi-producer single consumer. But I don't want we could use a mutex. Perhaps that's just what we need. Mutex. We need a mutex that we can check on at a specific rate and see if it's ready with a response. So we're gonna have let response container equals arc new mutex new, and inside the mutex we're gonna have a none at the beginning. Import, and here we're gonna have, yeah, I'm gonna specify that right now. So we do have the request struct right here, but we're also going to need struct response. So, and for now, content, I'm just gonna set it to a string. So in here, what I'm gonna do is once this is done, if it's okay, right? So the response res dot body dot turn this response into an implement read to the body if transfer encoding chunk needs a string. For now, let body, let's call this res body. For now, I'm gonna put really bad error handling, but I'm gonna make it better later. Expect unable to get body. And now I'm gonna do here a response container dot lock expect poisoned let mute response container. Perhaps I should add like not just an option, but a failed. I should have more information, but again, really not in the scope of this live stream. Perhaps on a later live stream, I'm gonna make this better. So now I'm gonna have to do response container equals some response content equals res body. Gonna have to reference this. Amazing. I'm gonna have to put this on another scope. Awesome. And our struct response, what is that? I don't know. Because maybe just the responses. Cool. So I think we got it. Mismatched. What did I mismatch? Expected, found, standard, mutex, option, right? So this actually of an option. Option. Awesome. Awesome. So I think we are in a good spot, right? So what we're gonna have to implement for the response is we're gonna need to be able to somehow tell, how do you call this? Hey, awesome. So we're gonna be able to a way to poll, because this response container is basically a future, right? It's a promise. Um, it may or may not contain the content, so we're gonna need a way to pull it. So let's create a pull function. Is gonna have to take in self, and it's gonna return. How should I return this? Oh, because it could be done. It could. Okay, let's just have it return a boolean. We'll worry about the details later. So this would be self dot response container dot lock dot is well, um, let response container equals this dot expect send voice right. And response container dot is sum. So the response container, we're gonna lock it for a tiny fraction of a microsecond probably, and we're gonna check if it's sum. If it's not sum, then it's not ready yet, right? And we should also have a function of get content string for now. This should also be an itself. And here we're gonna return a string. We could return an option or something, but again, why do I keep clicking that instead of the curly brace? After it is resolved. We're going to do the same strategy as before. Actually, it's going to be like a sum string. Why am I not getting the autocomplete that I need? Container and add new content. It's response container. Good. Response content, right? So how is it that you? I forgot how to do this. Oh, like that. Awesome. Oh, dereferencing. It's always interesting. Awesome. So I think we have everything we need to do. Let's do a quick cargo check. No warnings, no anything. Perfect Rust code. Awesome. Okay, cool, cool, cool. So let's do a little R extender document. Damn, so many dependencies. And the thing is that our like the Rust, what do you call this? The cran, not the cran, just cran. Doesn't allow for like very big parallel compiling, which I don't like a lot. But that's what we got. So we're gonna have to wait a while for it to compile, but it's okay. Ever wonder why your R packages probably take so long to install? That's probably one of the reasons. Um, like we literally have to limit it to like 2 jobs maximum for compiling, which is pretty bad, but awesome. It's documented. Let's leave here. Awesome. We can go back to our. Ooh, I haven't get init. Get init. Awesome. Now let's go to our verbs that are. Gonna split our screen and go back to our extender wrappers that are. Okay. So what I'm gonna first do is define it. I didn't implement a way to start the HTTP client. Okay, function new. Let's pass in an argument num threads, which should be an I32 because R only accepts I32s, and should return an HTTP client. And let's keep it that simple. So let thread pool equals rayon thread pool builder new thread pool new takes and deprecated in favor of thread pool builder. Yes, I want a thread pool builder new. dot num-threads as usize dot build dot expect unable to build the thread pool. Amazing. Semicolon. Let agent equals urec agent HTTP client agent thread pool. Done. Awesome. OT R extender document. Enter. Wait for compilation. Look at this, look at this, look at this. This is what's making it slow. The build J2. I have more threads than 2. I'm on my laptop. It's not a powerful laptop. It doesn't have a good CPU, but limiting it to 2 threads is like just bonkers. I wish there was someone in chat that I could chat with someone. Top chat, live chat. Yeah, no one's typing here. Pretty sad, pretty sad. Would love to be able to talk to you guys. While things compile, but I have no one to talk to. I'm not even sure if the audio is working. Yep, the audio is definitely working. I don't know. I don't know. It's not the best audio. I'm sorry, you guys, but gotta deal with what I have, and I currently don't have a better microphone where I am. Ah, you're okay. Let's just keep waiting for things to compile. I think I am able to set a not cran. Yeah, because I do hear the .cargo. Okay, it's done. Okay. So in our verbs, I don't know why I called it verbs. We're gonna need to set up a global agent. So global agent or global HTTP client would be a better. So let's set this to HTTP client new, and the number of threads. I'm gonna put in 4 threads for now, just to have something. And we're gonna start by doing this. So when we when we use the post, what we're gonna be doing is we're gonna do a request builder new, and we're gonna be passing out the URL. So URL, and let me just request builder new the URL, right, and the verb, right. So the verb for post is post. The verb for get is get. The verb for put is put, and the verb for delete is delete. Awesome. Cool. So now when we do a set header, what we're going to be doing is request. Well, we're going to take the request builder, and we're going to be doing a set header. And we're going to be setting the header name and the header value. Amazing. And when we set the body, we're going to be taking, for now, let's set it as body raw. So let's do it as send. No, let's just do it as body raw. And let's do request set body raw as raw contents. And send request, what we're going to be doing is we're going to do request send request, and we're going to be passing up the global HTTP client. And this should be our HTTP library. We're going to need to add to do. Make this a promise. So let's make a promise. I kind of want to. Nah, should I test out the library before making it a promise, or should I try to complete it before running any code? Because I haven't run a single line of any of this code. Like I'm so confident in Rust that I am very sure everything here works exactly as I want it to. So I don't really see a need to run the code. Like I'm just gonna ship this to production without even running the code once. And I'm confident it's gonna work. Like I'm not sure. I'm very confident that it's gonna work. So let's make this into a promise right now. So we're gonna need a promises promise. Create a new promise. A promise is a placeholder object for the eventual result or error of an asynchronous operation. This function is not generally needed to carry out asynchronous programming tasks. Instead, it is needed to be used for package authors, and we are package authors. So we're going to be using the promise function. If I am not wrong, the promise function will take in resolve and reject. So both of this are action, a function signature, resolve and reject. Right. So I closed the thing that I did. So verbs. So right here, I'm gonna pass a function with resolve and reject. And we're gonna press enter, we're gonna do this, we're gonna do that, we're gonna pass in here this, we're gonna And so first we're gonna send a request, right? And remember that send request returns a response. How did I call it? The lifted RS. It just literally returns a response. Okay. So this is gonna be response. Let's call it. Let's call it eventual response, right? Because it's probably not a response yet. So inside the promise we are building, what we're gonna need to do is do a later, and later runs things later, right? It's basically a set timeout, and we're gonna need to do a recursive later call, which I don't remember how to do. I haven't done this in quite a while. I haven't written any asynchronous hard coding. So if I am not wrong, how do I do this? How do I do this? I forgot. I forgot how to write a later. It's super recursive. Let's go into the futures package. Our future promises. Oh, they have such a great example on how it's done. How did I forget this? I did this so many times before. Our future promise. what did I forget? So I do remember I have a package for that. I've done this before, async. I've done this on the Expont here repository. Right, so I need to define a function inside the later checkpoint interval. Yes. So inside here, this is like create a function inside a function inside a function, right? So poll is equal to a function. Inside this function, what are we going to do? We're going to take our eventual response and we're going to poll it, right? Because this is what we do in the lib.rs right here. And we have in response, we have poll. So what we're going to do is ready. So if is ready. So if our response is ready, then we're gonna resolve with well, contents would equal, because now this is like only the string contents. Again, we could make this way better, but for now, managing only strings I think is fine. So string contents would be the eventual response get content string. Why am I putting semicolons? And then I'm gonna resolve with the string contents. If not, I should call later poll. And if I'm not wrong, this doesn't take, yep. So later poll, and the poll interval would be, let's set it to what? It would be cool if we would let the user select the poll interval. For now, if I am not wrong, the poll interval is in seconds. So 5 milliseconds, I think 5 milliseconds is a good. So we don't check for, how do you call this? Yeah, I know there's no global definition of. Let's put this cursive. I think we're done. I think we have an HTTP, an asynchronous HTTP library. Of course, a lot missing. Documentation, handling the other verbs. I think we don't handle them yet. But we can. Our extend. We could just do dev tools document. I don't have that tools installed. Dev tools. I wrote this wrong. Dev tools. Hi, MO. How are you? Thanks for the message, I guess. So we're almost done, which it feels bad that there's like people online now that we're almost done. But um, the oh, what happened? Wrap HTTP car extender document. I think we need to do it. Right. Control T, then. Oh, no, no. Live.rs. Client response. Yeah, this looks good to me. R extender. Right. I don't know what just happened. Okay, let's wait for its document. And we should install the package right after that. And once we install the package, let's try it out. Let's test our asynchronous package. So we should be able to have some sort of slow API in front of, but I don't know. I don't know what the best way of doing this, like testing it out would be. Like the cool part would probably be creating a really slow API and having some sort of shiny application where we just click a button over and over and it just asynchronously runs the requests. Perhaps that's a good idea. I don't know. I have no idea. If someone has any idea on how to make this cool, I'm all ears because I have no idea. Okay, it's compiling. Done. I don't get this. I don't know what's going on with my HTTP client new. I have right here. I have right here. Is there a bug in R extender? Okay, I get it. I need to lazily do this. But how? Yeah, I get exactly what's happening now. So perhaps this should be async HTTP and when we send it, where's the send? Send request, right? So if is null um, async dot client, then async client will equal this right here. Awesome. Now it works. Dev tools. What happened? No matching package Rayon? What do you mean? Oh, it's offline. I need to render it. I hate this. I absolutely hate this. Oh, Cran makes my life hard, but it's fine. Do I have vendor on right here? Yeah, so we have the already takes care of the tar. Our extender, vendor, vendor packages. There you go. Yeah, 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 yeah. Is it done? Seems like not. What it's doing, I have no idea. I think it doesn't matter. I think it just looks like the tools. No. Oh, it was compressing it. Oh, let me vendor the packages again. I'll just have to wait. It's fine. No, it's fine. It's fine. It's fine. It's fine. Yeah, so I don't know who's watching right now. Um, but thank you for being right here. It's fun to not be alone while writing this stuff. I don't know if you've seen my keyboard skills. I I hope it's not very rough. I hope it's okay. I'm trying to get used to this keyboard and it's not been the easiest of tasks. But it is what it is. How long is it gonna take to write this? Oh, it's done. Nice, nice, finally. Okay, DevTools install. It's compiling. Let's go. Okay, 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 okay. Cheers, man. Great content. I missed the beginning, unfortunately. It's fine. This is gonna be recorded right here on the channel, so you're welcome to watch it again. I hope you guys saw me struggle with the promise. I just couldn't remember exactly how you did it, but I guess this is like the way of doing it. Yeah, we're pretty close to finishing. I'm just gonna write like a very like I don't know exactly how to what I'm gonna do to test it out because I'm gonna need like a slow API too. It's hard to test like that it is actually asynchronous. Hard to show it. I'm gonna try my best. I think the easiest way to do it would be to kind of run the request, run something else, and then print, like then wait for the result. Literally slow API. So I don't see your suggestion. I don't know why. Look at my suggestion above. Literally slow API. Hey Devin, I don't see your. Did you send any other message? Is moderator activity, reactions, timestamps? Huh. So I'm gonna build. Okay, it's done. Awesome. We have our. So let's test it out. Let's open R. Let's do future plan future multi-core. Awesome. Just to have it out. Scroll. It was before GG. This is weird. I don't see it. I think you're. Yeah, my big. Let me pop out the chat and put it right here to the. Let me show you that I truly do not see your suggestion. Um, Look. Oh yes, the URL. Maybe. Do you have a way for me to search for it? So HTTP. Let's do it. HTTP stat.us. It is super simple service for generating HTTP codes. It is useful for testing your own scripts, dealing with various responses. Seems perfect. So for the slow API, check out the query string sleep. Let me look for it. So sleep. If you want to delay the response, add a query string to the provided header of. Awesome. I like this. I like this a lot. So this is gonna sleep in seconds, right? Let's test it out. Let's do it. So if we do async HTTP, which is our library, and we do a get to, I'm just literally gonna copy this. Copy. That's an awesome suggestion. Let me do shift. Oh, I pasted it wrong. Let me just do shift paste. Shift paste. Oh, it's copying all the like the special characters. Let's do 5 seconds, right? So if we do this, then we pipe it to what? To send request to async HTTP send request relative URL without a base. I forgot. Of course. So http:// we get a promise pending. Yeah. Oh, this is in milliseconds. The time is in milliseconds. You are absolutely right. So sleep 5,000 should be 5 seconds, right? So this again says promise pending, and I'm currently not doing absolutely anything. Yeah, 5,000 is definitely 5 seconds. Just that I got a little bit confused because it's at 5 minutes, and here it says 5,000 milliseconds, and I got a little bit confused. Thank you, Devin. So what we're gonna want to do is gonna bring in our library. How do you call this? Promises, and we're gonna run the same. But I guess you have seen this already. It's the this. I think it's like this. And we're gonna this basically what this will do is it's gonna tell us to print the result when it's ready. 200, okay? Look at that. So as you can see, let me make this 10,000 so that we can have like a little bit more time to kind of 10,000, right? So we can press enter, we can print hello. It print hello, but after the 10 seconds, it should print 200, okay? Sometime, there you go. Cheers, gotta sign off, sing on an Uber. Awesome. Thank you so much, Devin. So, yeah, we have an async HTTP library. I think in another stream, time should be dedicated to documenting this, making this a little bit more robust, because it's definitely not robust at the moment. But we do have this, so we can run this like we can run something like this, and we should get in about 10 seconds a bunch of 200s. Why am I only getting 4? I expected more. Okay, there's another one. There's another one. Maybe it's because of the number of threads we have in the thread pool. We should probably have more than just 4, so we can send at most 4 at a time. It's still asynchronous. So even if we only have 4 threads to run on, it's still asynchronous code. It's still non-blocking. So this, I think this is a success. Thank you, Devin. Again, I know you left, but this is basically how to write an asynchronous library for R. I'm going to be posting this on GitHub. And let me just do this. Let me do the commit and things. So git branch minus main. Git dot git commit dash no adds async HTTP requests. That's what I did. Awesome. So I'm going to be posting this on GitHub right after the stream. And yep, I'm going to put it in the description of this video. And I think that's it for now. Awesome. Thank you all for watching. I'm going to be making this better probably on the next stream. And yeah, thank you so much for watching. See you.